Hi guys, this is Jonathan Lambert with Maths and Stats, and this video, another video in our series of videos dealing with calculus and limits. It's going to look at what is, I suppose, a very important limit, especially when it comes to finding limits of trigonometric functions. Okay, and also other functions. And the limit that we're going to consider here today is the limit of the ratio of sine x to x, where x is measured in radians. Okay, so the limit of sine x over x as x tends to 0. And what we'd like to do is we'd like to come up with a way of showing that that's actually equal to 1. And the way we're going to do this is that we're going to bound sine x over x. We're going to bound the limit of sine x over x by a value below and bounded by a value above. And we're going to show that both of them values are actually equal to 1. And hence we're going to deduce from that this particular limit is also equal to 1. And how we're going to do that is we're going to consider the unit circle. So here's a unit circle. Its radius is 1 unit. Just keep in mind that any point on this particular circle, that any point on the circle can be defined in terms of sines and cosses, okay, depending on the angle that it makes. But I'll just say that if we have a point in the circle here, the point can be defined in relation to its x coordinate, okay, which will be a certain distance away from the origin O here, okay, and that distance is effectively cos of some angle, okay, and the vertical distance here, its y coordinate is going to be sine of theta of some angle. So just keep that in mind. This is some characteristics of the unit circle, which we're going to need for this particular proof. And what we're going to do is this first is we're going to construct a sector of the circle. So here's the origin here, okay? This point here, the intersection of the unit circle with the x-axis is obviously at 1 unit away from 0. So its coordinate would be in, let's say, if we were to go into, let's say, Cartesian coordinates. This coordinate here of this point, let's call it A, would be 1 0. Okay. But we just have this particular point here, and what we're going to do is we're going to sketch out a sector of the circle. We're going to construct an arc of the circle, okay, by moving around in this particular direction. Let's say to another point, and let's say, for argument's sake, that we call this point. Let's do it. Let's maybe do it up. Let's just do it up here. Let's call this point the point B. So effectively now what we have is we have a sector of the circle. And let me just get my ruler just to draw that sector here. This is quite a big ruler. So now we have an important sector that we're going to keep an eye on. Okay. And the sector that we're going to keep an eye on is the sector AOB. Okay. So what we have is we have a sector of the circle. And the sector that we're interested in is the sector, OAB. It's the sector OAB. That's a sector that we have. And what we're also going to do is we're going to create a triangle. We're going to extend. We're going to join the line segment that's bounded between A and B. So we're going to join that line segment here. Okay. So now what we have is we have a triangle. So we have a triangle now created. The triangle is AOB. So the triangle now is AOB. And also what we're going to do is we're going to create a tangent at the point A, and we're going to extend that up. Okay, upwards, and we're also going to extend the line OAB, extend it in this direction until it meets the tangent line at A. Okay, so I'm going to take this particular line up here, and I'm going to extend it out. I'd say if I extend it to around there, that should probably do the job. And we're going to extend this up a little bit. Okay, so we're going to extend this particular OB. We're going to extend that up here, sorry, just in this direction. Just a little bit of construction to do here so that we can actually attack the problem. So now let's call this point the point C. So we have now another triangle. Okay, the other triangle is AOC. So we have another triangle, which is the triangle AOC. Okay. Now let's just have a look at these particular sections that we've just constructed. I think what we can see is that when we look at the triangle AOB, okay, so this particular triangle in here, AOB, its area is definitely less than the area of the sector, okay, of the sector OAB, and the